who has joined. Okay. Wait. Okay, Lavella has joined. Lavella, I'm going to be sharing my screen very soon, but for now, I think what I want to do, it is to get to the question paper that we're going to be tackling in today's lesson. Maybe while I look for that, Lavella, can you let me know what is it that you guys are currently busy with in your school?
For physics, yeah, we are doing chemistry.
Yes, I did suspect that it is chemistry, but did you notice my message regarding when the chemistry days are on our lessons?
Yes, sir.
Yes, okay. So that means every Tuesday we are going to be doing the topic. And the reason for this is so that come exam time, you won't have to start over to revise this topic. So let's see how far we can go. I'm not really sure what it looks like. Someone's mic. It is not muted. Okay, then it's fine. It looks like we are now okay. So what I want to do, it is to share my screen. Okay. My screen, I believe it is sharing now. So let's see. Guys, can someone just confirm if you are able to see my screen?
You can see it, sir.
Okay, then it's fine. So let's see. And it looks like okay, it's fine. It looks like the battery has just died for my piece. Okay, then it's fine. So question number 10, they want you to start on a new page. So what I'm going to do very quickly, it is to read through that given statement. We will also have a look at those questions. So 10.1, they are saying the circuit below, it consists of a 6 ohm and a 15 ohm resistor connected in parallel and an unknown resistor R in series. An ammeter, a high resistance voltmeter, a closed switch, and battery are connected as shown. The resistance of the battery and wires can be ignored. So we are given a circuit diagram that we will interpret just now by mainly looking at the flow of current. We know that the flow of current will flow like that. When it gets there, it is definitely going to split because this is the start of a parallel, meaning some of the current will flow through that side, some of it will flow through that side. This is the splitted current. And then when it gets there, it flows as unsplitted current. Once you understand this part, you will definitely go far, honorable members. So that means we have 6 ohm resistor connected in parallel with the 15 ohm resistor. We have resistor R over there, which is connected in series. And then we've got a voltmeter connected across that resistor R with that ammeter connected in series, which means it reads the unsplitted current, or the current that is going to split in that parallel connection. There is an additional information that we are given there, where they are talking about the total power dissipated in the parallel part of the circuit, which is 50 watts. W stands for watts. Now, 10.1.1, they want you to define the term power. So guys, how are we going to define the term power? This is an opportunity where very quickly you can check from your notes. If you can't find it from your notes, then it should be there in whatever textbook that you use. But you just need to find it and let me know what is the definition of the term power. Anyone who wants to give it a try. Quickly check who's on the line. Guys, can someone define power? Ethan, Lavella, and Lady, or Philevino, anyone who wants to give it a try. The term power. Okay, I'm going to do this and check a formula that talks about the power. There is the formula which says work over time. Remember, everything which is being divided by time, it's called the rate. So it looks like power, it will therefore be the rate at which work is done. That's how I would define power, by just looking at that formula. Guys, did you hear what I said? Does it make sense how I easily define power? Where P, in terms of the formula, it is equals to W over T, meaning power is the rate at which work is done. Did you guys understand how I define power?
Yes, sir.
Yes, sir.
100%. So power is the rate at which work is done, full stop, by just referring to that formula. Okay, so now they want you to calculate the effective resistance of the parallel connection by just looking at the marks allocated to that question. It definitely indicates that it is something that you've learned in grade 10, where you would be given 3 marks to do that calculation. But because you are now in grade 11, they no longer give you those many marks, they give you 2 marks. So very quickly, work it out. As soon as you get an answer, you can just unmute and say, I'm done. Whoever who is done, unmute and say, I'm done. Or if you are not able to unmute, what you can do, it is to comment in the comment section with whatever answer that you got. 2 marks for you to do that. Guys, are you still working on it? Vino, I'm curious to know, okay, someone got 4.29 ohms. Yes. Vino, instead of trying to speak using the mic, just type. You see there, it says chat. Type there if you've got a question or if you have an answer.
No, I need help. Help me. Any answer. What is power? The rate at which transform.
Vino, have you got a question?
Yes, sir.
Vino, is it a question? Yes. What is the question?
I wanted to ask the sister one the definition of power.
What did you want to ask?
Does sir still want the definition of power or did sir get it? Please don't do this. Do this. Then the letter quiet. Maybe gaan nie kinders my hart nie. No, the error is trying to.
Guys, are you still working on it, or what's happening?
Say,
Yes.
I have a question.
Yes. Ask very quick before you start breaking. Vino.
So I wanted to ask, does Sir still run the definition of power or
So Vino, you are breaking, but I think you wanted to know the definition of power. It is the rate at which work is done, full stop. The rate at which work is done, full stop. I wonder if you have moved to the second question, because that's where we are. But let me see. Okay. Ethan got 4.29. Let me quickly work it out. I'm just wondering what's happening there. But we know you are breaking, honorable member. Just try to use the chat box. Don't know, but I'm well aware that you are struggling with network on your side. So just try to use the chat box. Don't unmute yourself. Okay, so now let's see. When it comes to 10 point, let's see. When it comes to 10.1.1, we said rate at which work is done, and then we said full stop. 10.1.2, the effective resistance of the parallel combination. The formula for calculating R parallel is 1 over R parallel equals 2, 1 over R1 plus 1 over R2. You just substitute, you have 1 over, it's 6 and 15, so you have 6, and then you have 15. Then what you need to do, it is to therefore, remember this is 1 over R parallel. And then I said, you now write R parallel, you say, you rewrite exactly the same thing, but to the exponent that. Therefore, you punch that on your calculator. What do you get when you punch that on your calculator? Are you getting what Ethan got?
Yes, sir.
Okay. Someone did confirm that it is what Ethan got there. Let me quickly check what Ethan got. It's 4.29 ohms. So that means the answer is 4.29 ohms. Okay, then it's fine. So now moving on to question number 3, 10.1.3, they want you to calculate the potential difference across the resistors in parallel. The potential difference across the resistors in parallel. Let me not say much, but I will also give it to you guys to work it out. Let me not say much, but give it to you guys to work it out. As soon as you are done, unmute and say I'm done, because I'm not able to see in the comment sections. So I can only rely on you saying you are done. Let's see. Anyone who is done? Do this. So do that. I'm going to check. Okay, nothing in the comment section. Guys, is it difficult or are you working on it? I see someone there on Zoom is just a dot. I'm not really sure who that is. Ethan, Lavella, and Lady Orphila Serene, and Vino, are you guys still working on it? Or what's happening there?
Still working on it, so.
Okay, still working on it. Maybe let me not rush you, but give you enough time to work on it. just remember to let me know as soon as you are done with the calculations, because I'm also looking at what you guys are seeing. So if you commented, don't let me know, I won't know. Okay, let me quickly go get myself a glass of water. I'll be back. Okay. Senguyile manje. Senguyile manje. Let me check if you guys have worked it out. I'm not sure if you were. No comment. Okay, anyone who commented to say they are done? Dot, Ethan, Lavella, and Lady Orofile Serene, Vino. Anyone who commented they are done? Or is it difficult? Or what's happening? Guys, what's happening there? Calculate the potential difference across the resistors in parallel. Okay, what information do we have?
Please give us more time.
You still need more time. Who commented? Was it you, Vino, requesting more time?
Yes.
Okay.
Yes.
It's fine. I'm just going to make you guys aware that the reason why I will not give you more time is because in an exam, you won't be given more than you had, because you look at the marks allocated to this question, realize it is allocated 3 marks. So that means you were expected to be done a long time ago, but I'm just going to guide you in terms of how you should work it out. You need to ask yourself a question to say, what information do I have about parallel? So, okay, we have a statement there which says the total power dissipated in the parallel part of the circuit is 50 watts. So we have the power there, which is equals to 50 watts. What else do we have? We have R in the parallel. You guys said it's 4.29 ohms. What does examiner want? They want V being the potential difference across the resistors in parallel. Let's go look for the formula that has P, that has R, that has V. So you go to the formula sheet that you are given there. Let's see, do we have that formula? This is where I'm looking at because that's where we have the power. I can't use that one because I don't have time. I can't use that one. I don't have current. I can't use that one. I don't have current. It looks like this is the one to use because it has V and R. Okay, so that means the formula to use is this one which says power is equals to, what was that? Was it V squared over R, where the power they said is 50 watts. V is what they are looking for. Ethan said R is 4.29. That means you can just cross multiply, meaning V squared equals 50 multiplied by 4.29. And then for you to get V, that's if you say square root of that 50 multiplied by 4.29. The answer that you get, it must be in volts, and that's how you calculate it. So let me quickly punch on a calculator and see what I'm getting when I punch that. It is square root of 50 that you multiply by 4.29, and then you're getting 16.65. So you have 16.65. That's if you round it off to 2 decimal places, and this is how you work it out. Guys, did it make sense to everyone regarding how you work it out? Normally in physical sciences, you are given a mark for correct formula, a mark for correct substitution. They don't give you mark for those calculations because they know you just apply your maths. But what they do, it is to give you a mark for that. Is my screen sharing? Yes, I think it is sharing. Okay, guys, did it make sense how you are supposed to work it out?
Yes, sir.
I hope everything's in order on your side. Ethan, okay, thanks for the confirmation. And maybe let me do this because I want to chart. Guys, is it everyone who saw how to work it out?
Yes.
I believe so. Okay, then it's fine. And no, I did not want to do that. Okay, luckily that did not disappear. Okay, so now they are saying calculate the current through resistor R. What a question. The current through resistor R. What will that be? What is the current through resistor R? So all that you need to know is that the current passing through resistor R, is it the splitted or the unsplitted current? If that is the case, do you have enough information about resistor R? Yes or no? If the answer is no, then if you have enough information about that parallel connection, can you not use that parallel connection to do some calculations and then say, based on what I know, the current through that side and the current through that side, when you do them this way, it means it's the same as whatever. I think I've given you guys a hint on that one. For now, I will just wait and give you guys some time to work it out. But just always know that you do not always have enough time to work these things out. You need to be as quick as possible. So that's why I'm also giving you, or I'm going to give you a limited time to work it out. But let me not rush you, but give you some time to work it out.
Beauty shop.
Guys, are you still working on it, or is there anyone who is done with that question? Okay. 3.1 for 1 amperes. Okay, the answer noted there, Ethan. Last one to confirm. Lavella, Lady Orfile and Serene, are you guys working on it? What's happening on your side? Guys? Okay. Guys, are you still working on it, or is it difficult?
You say?
Yes.
Sure. Okay.
Yes. I don't know why, but she's going to say gay. Then when she has to ask a question, network problems. Vino, can you be able to type? It looks like your connection is troubling you on that side. Can you be able to type a message? Okay, let me do this.
Yes, sir. Okay, sir.
Okay, so it looks like what Ethan has done there is the correct way of approaching that question. I'm just going to explain now in terms of how you work it out. So, let's see. What question is that? This is question 10.1.4. Okay, to do that. 10.1.4. We want to know, in short, the combined current, because the combined current or the unsplitted current, it is the one that is passing through resistor R. So if we don't have enough information about that resistor R, we can just use the parallel connection to calculate the combined current. So that is why we are therefore going to just say the V on the parallel will be equals to the current passing through the parallel multiplied by the R of the parallel. What we know is that V across the parallel, we just calculated it to be 16.65 volts. This should be equals to the current that is passing through the parallel. And remember, this is the unsplitted current because we are now going to use the resistance of the parallel, which was 4.29. 4.29. So that means this current that we are going to get, it is the one passing through the parallel connection, or it is the one passing through the series connection, or it is the one that is passing through resistor R, or it is the unsplitted current, which is equals to, then you punch that on your calculator. You are just going to say that divided by that. What does it give you when you say that divided by that? Let me also see if I can punch it on the side. And let's see. That. Let's see. That and that, yes. So, this is the answer that you get. I equals to 3.41 amperes, which is what the honorable member got there. So this is it, honorable members. I hope you guys did understand how to work it out. Otherwise, if not, you will therefore let me know. Let me just check what's happening in the comment section. Can I say the V value is wrong? Did I use the wrong V value? Let me quickly check. Wait. Okay. And let's see. Someone is saying my V value is wrong. Let's see what's happening there. Square root 50. That should be multiplied by 4.2. Oh, yes. It looks like I wrote that. It looks like I wrote that based on something else. So the V value, thanks for that, Ethan. So the V value, it is that 14.65. 14.65. Okay, I see where that is coming from. It's a value coming from my other lesson. Just mixed my calculation. So that means the V for the parallel, it is 14.65. And then when you say that divided by that, that's when it gives you that, which is what Ethan got. Then you get a mark for correct that. Then you get a mark for correct substitution, mark for correct final answer. Okay, so now we have got those two questions there, which you will need to very quickly work them out. Then we'll do the corrections. I'll just give you, 3 minutes to work on that one. Okay, looks like it's time up. Looks like it's time up. Okay, so this is what happens, honorable members. I just explained this on yesterday's lesson with the grade 10 learners to say, when the switch in the circuit is opened, so that means you are now removing the parallel connection. When you remove the parallel connection, it's like now you're converting it from being parallel to being series. And when that happens, what happens to the R is that it increases. Always, when you change from parallel to series, R increases. And when R increases, the current decreases. So that means in answering this question, the reading on the reading on the voltmeter, maybe let me quickly check, because what I'm now responding to, it refers to what happens to the current. But it looks like the question now, there they are talking about the reading on a V. So let me rephrase and then explain that part. So the switch in the circuit is now opened. Yes, okay. How will the reading on the voltmeter V be influenced? No, it will remain the same. It will remain, how will the reading on the voltmeter V be influenced? Do we choose from that? No, it has to decrease. It has to decrease. I will explain why. Remember, V is equals to IR. V is equals to IR. So what I've just explained is that the moment you open that switch, you increase R, being the total resistance of that circuit. What happens to the current? It decreases. So that means that R for that one, it stays the same. But because the current decreases, so that means even your V, it's going to decrease. That's what happens there. And that is how you are going to reason there. I hope that part makes sense. So maybe very quickly, we can go through those last two questions where they are now saying a geyser labeled 2000 watts is used for an average of 5 hours per day. The cost of electricity is 80 cents per kilowatt hour. Okay. Now they want you to calculate the energy used by the geyser for 5 hours per day. Calculate the energy. Work and energy refers to one and the same thing. So you do know what the power is, which is 2000 watts. What else did they talk about? Time, where they said 5 hours per day. So that means you've got your change in time which is equals to that 5 hours, which you might need to convert to maybe seconds, where you multiply it by 60 to take it 2 minutes, another 60 to take it 2 seconds. Then what you are looking for is work. Then you go check the formula that has power, work, and then time. Where is that? Is it not this one? I think it's that one. It is power, work, and time. Then that should be the formula that you need to use, which says power is equals to work over time. So that means use the formula which says power is equals to work over time. That's how you will score yourself 4 marks on that question. So that last question, it is the one where they say calculate the cost of electricity to operate the geyser for a month with 30 days. So there, it's a question that you can quickly work out as a homework, which we will finalize on our on our next lesson. But for now, I will leave it here, honorable members, until we meet again. I'm just hoping that all that we did in today's lesson made sense. Let's see. Any questions from your side before I sign out, honorable members? Or are we all okay?
Fine, sir.
Yeah, fine. Okay, then it's fine.